warahmatullahi wabarakatuh. My name is Mohamad Alif bin Roslan. So today I will present about SRF soil analysis to soil nutrient. So as you can see, this is my video presentation for subject AGR 491. So this is my table of contents. For the first is we have introduction. Second, we have about SRF soil analysis. Number three is how does SRF cell analysis work? Number four, type of elements. Number five, factors affecting SRF cell measurement. Number six, we have some clip. Number seven, we have conclusion, and the last one is references. So let's we go to number one, which is introduction. So this is introduction for SRF. So S X-ray fluorescence spectrometry or SRF is a quick method for determining of the total elemental composition of soil samples. Unlike many laboratory techniques, SRF does not require any acid digestion techniques before the sample is analyzed. Therefore, it can be a useful screening tool for agriculture. Okay, next we have number two, which is about SRF soil analysis. As you can see on the slide, portable X-ray fluorescent or SRF spectrometers with tube X-ray source are being used to determine the elemental composition of soils in the laboratory and the field. Most studies with SRF have been with mineral salts, and there is a need to assess SRF applications to organic soil and pits. If you want to know, PSRF and XRF is the same thing. Okay, next. SRF or X-ray fluorescence is a non-destructive analytical technique used to determine the elemental compositions of materials. SRF analyzer determine the chemistry of a sample by measuring the fluorescence or secondary X-ray emitted from a sample when it is excited by a primary X-ray source. So let's go to number three. How does SRF soil analysis work? SRF soil analysis work when the sample is illuminated with an X-ray beam and the atoms which are struck by the beam emit X-rays in response, usually at several different energies. Different elements produce different distributions of emitted X-ray, so the spectrum of emitted X-ray can be used to identify which elements are present in a sample. So this is number four, type of elements. In this type of elements, we have two types, which is type of elements that can be detected by SRF soil analysis, and another one is the type of elements that cannot be detected by SRF soil analysis. For type of elements that can be detected by SRF is as you know, SRF is a new technology being investigated for its potential to provide an accurate assessment of nutrient concentrations. So this is an example of key elements such as calcium, potassium, phosphorus, sulfur, and zinc in a wide range of crops. So this is type of elements that cannot be detected by SRF. SRF is not effective for lithium, beryllium, sodium, magnesium, aluminium, silicon, or phosphorus. The SRF cannot detect common elements that are considered to be like elements such as lithium, beryllium, sodium, magnesium, aluminium, silicon, and phosphorus. So this is number five, which is factors affecting SRF soil measurement. Factors that affecting soil PSRF or SRF measurements include organic matter, water content, heterogeneity, sample geometry, analysis film thickness, sample thickness, metric interferences, and detector resolution, X-ray energy and intensity, power source fluctuations, and instrumental drift over time. So for number six, I have some clip for you guys to watch. Number seven, which is conclusion. As a conclusion, SRF allows easy and fast sample preparation, and it has low operation costs. It does not involve the use of any gases, liquids, or acid in the testing process, which means it is a highly adaptable technique for use on site in different locations. This SRF is very good to use for farmers or domestic companies to ensure the nutrient content in the soil at the at their plant sites. So we already arrived the end of this slide presentation. Thank you for spending your time to watch my video presentation. Thank you. Assalamualaikum warahmatullahi wabarakatuh.